Hey, so let's quickly recap our first attempt for this question. Now, let me give you a brief um, overview of the question first. So, we have a bunch of prison cells which are linearly placed. So, there's one prison cell, then next, and they can be either vacant or occupied. So, they're represented by this binary array of zeros and ones, or binary list if I talk in terms of Python syntax. And what happens is that there is a simple rule, and after each day, if there's any prison cell, if the adjacent prison cells are either both occupied or both vacant, then it becomes occupied, otherwise it becomes vacant. So that's what is written over here, and this is the most important bit. Now, we have to tell the state of all the prisons after n days, and there are only 8 prisons, and that's the constant. Now, in our first attempt, so there are 10 to the power 9 days it can go up to. In our first attempt, what we did was we figured out that we cannot do it in a 10 to the power 9, so a brute force of going on over every day would not work. Then, when we were exploring, we found out that this would become repetitive because after some iterations, it would return back to normal. So we tried with zeros, we did a simulation, we found out that it repeats. Now we could not figure out what would be the time in which it repeats. So we did this hack where we keep doing the iterations, and as soon as we detect that it goes back, so given a start, given a state, it would definitely go to the next state which it went from that state, no matter when you do it. So because that's the only input, right? Only given all these 8 numbers, it's gonna have a deterministic next outcome. So at any point, if it goes to any of the previous ones, then it's gonna get into a cycle. Right, so what we did was we have this dictionary called memory. Now, for all iterations can be from 0 to n minus 1. Um, Now, most likely it would not go till n, it would only go till the repetition occurs. What we do is we create a copy of all the states in O cells. The reason we do this is because if we keep updating it again and again while iterating, our answer would get corrupted. The reason being, say you were at the third cell, the neighbors are the second and the fourth cell, and if you're iterating from left to right, which was what we were doing in our case, then you've already updated the value of the second cell. Now, when you're checking the neighbors of third cell, you're checking the second cell, but you need the old state, not the new updated state. And if they are not the same, your answer will be wrong. So that's why we create O cells. Now we only go from 1 to 7 because we definitely know that the edges have only one neighbor, so they're going to be 0, which we're setting right here. We go from 1 to 7 indices, and we implement the logic, which is quite simple. If left and right both have the same value, then it's 1 in the middle, otherwise it's 0. What we do next is if we check whether or not we've stored anything in memory, the variable memory. And if we have, then the first item that we ever stored, if that is equal to what we currently have, then we break out of it. So that's when we detect a cycle. If we detect a cycle, break. Otherwise, we save the current state in memory in the iteration. And then what we do is we check how many states we've saved in memory. So that's rep. We do a n-1 mod rep because so these are list indices, right? So at the 0th indice, we are storing the day 1. So if n is 1, we want to get the 0th index. And similarly, we want one previous index for any element. So k minus 1 is what we're going to get. And mod rep is just because it's cyclic and circular. You're going to get this code and go down to the description. You would have the code uploaded in a gist.github.com, and you'd also have all these links along with the solution video, which I'm going to post now, and the in-depth think out loud session as well. Thank you. See you.